Okay, so this is for exercise 6. 86 marks. You all get that? Okay, median score 84. You all get that? 84.5 ah. How do you find the median ah? Okay, so we need to arrange them, right? How many numbers are there altogether? How many? 20 students, right? Hey, class. There are 20 students over here. What is the middle position? Is it number 10? Is 10 the middle position? Is it? So we need to find out 20 plus 1 divided by 2. What do we get? 10.5. This is the middle position, or otherwise known as the median position. Okay? Do I have, if I arrange all these 20 numbers out, if I arrange number 1, number 2, number 3, number 4, is there a number 10.5? No, right? But I require the value at number 10.5. What shall I do? I will find the average. The average marks for student number 10 and 11. Where is student number 10? Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is this over here, student number 10. This is student 11. Agree? How much did student 10 get? 84. How much did student 11 get? 84. So the middle position being 10.5, I require the average of these two values. Understand? So what is the average of 84 and 84? 84. Okay? Do not confuse it with this 84 and 85 that you take the middle. Different, huh? Okay, so median is 84. What is the mean score? So mean, I require working. I at least must see a fraction. 1561 divided by 20 to give us 78.05 marks. No? You didn't get that? Next one, question 7. Represent the data using an ordered stem and leaf diagram. Okay. The key 75 0 represents 75.0. Can? Okay, B part 1, 2 over 3. Part 2, 30%. Find the mean. So we add everything up. 1159.8. Right. So now we have learned how to calculate the mean, mode, and median of ungrouped data. Ungrouped data, I didn't group them. I didn't group the data. For example, I didn't say what. I grouped them into 0 to 5, 6 to 10, so on and so forth. I didn't do that. They are all individual numbers, as shown in our dot diagrams, as shown in our stem and leaf diagrams. So what happens if we now group this information? Maybe like people below 10 years old, people from 11 to 20 years old, another group, 21 to 30 years old, another group, so on and so forth. That will therefore be called group data, okay? So over here, fill in the blanks. We call this data grouped data. And we shall see some examples. Okay, to calculate the mean. In other words, our primary school knowledge of average. I want to calculate the mean of group data. There is a formula we will use. It looks like this. X bar equals to summation fx divided by summation f. Does this look familiar? Isn't it exactly the same as what we learned previously? But there is a problem now. When I group the data, for example, I say that there are 10 people who failed, 20 people who passed. What is the average? Can you tell me? 10 people failed, 20 people passed. Can you tell me the average if I don't tell you the exact values that they have? That will be our challenge. Okay, so we can only obtain an estimate. Okay, let me repeat the example. 10 people fail, 20 people pass. What do you think is the average score? Is it a passing or failing grade? But do you know how much is it? Why not? We don't have the exact marks of every single student. And the reason why you're not sitting down is because people are still talking. Okay, so you need to work as a class. But you are able to tell me that on average, probably it is a passing grade, right? How are you able to tell that? Is that an estimate? Yes, that would be an estimate, which is the best that we can get from group data. We only can get estimates of the average. I cannot have the exact average, okay, because I don't have the exact values. So I need to write this down. This x over here, you know, previously our x values, they are our actual scores, right? So if I have 3 people who got 10 marks, I'll be writing 3 times 10. If I have 5 people getting 20 marks, I'll be writing 5 times 20, right? F will be for the frequency, the number of times it happens, whereas X will be the data value. Now in this case, if I group everything together, do I have the exact data values? I'm not going to have the data values anymore. So what exactly is X going to be? This is what you need to copy down. This is the mean value. If there is a class interval. Okay, you may sit down now. Alright, so let's take a look at this example over here. Number of goals scored by a soccer team in 30 matches. How many matches are there? 30 matches. If I were to add everything up, I find the summation in the bottom row. What do you think I will get? If I add all the numbers at the bottom row, what do you think I should get? 30 lah. Okay, let's just do a quick check. 17, 27, 29, 30. Yeah, it makes sense. There are 30 matches. Out of these 30 matches, how many matches did they score? 0. 5. Good. How many matches did they score 3 goals? 2. So everybody can read this table easily. Okay. Write down the mode. Okay, what is the mode? What's the mode? What's the mode? Can you tell? What's the number of goals? 1. Okay, I hope you don't think that the mode is actually 12. Okay? The mode is the number of goals. It is the value. The value is 1. How many times did the 1 appear? 12 times. Okay, so don't get confused. Now, find the mean number of goals for each match. That's also not difficult. Mean number of goals, 0 times 5. I want to find the total number of goals, alright? Plus 1 times 12, plus 2 times 10, plus 3 times 2, plus 4 times 1, divided by, what's the denominator? Do I need to add again? 5, 12, 10, 2, 1? No lah, the question already told me it's 30. So this gives me my mean number of goals. Mean equals to this. 42 over 30. Which is 1.4 goals. Okay, I want you to compare this working with the formula. X bar equals to summation fx divided by summation f. I shall now highlight to you what all the individual f values are. Frequency, f for frequency. Okay, there are 5 matches with 0 goals. There are 12 matches with 1 goal. 10 matches with 2 goals. 2 matches with 3 goals. 1 match with 4 goals. Okay, so the green color highlighted parts, they are referring to the frequency. Then what about the x value over there? So this x value refers to the number of goals. 0, 1, 2, 3, and 4. You get how this works? Then summation f at the bottom. Let's use... Okay, summation f at the bottom will be adding up all the green numbers. And I get 30. Any questions? Straightforward. So you are familiar with the usage of the symbol summation? It's all over here. It just means adding up only lah. Okay. Now I want to put everything in a table form. At the bottom, I'm simply copying down the values. Number of matches will be 5, 12, 10, 2, and 1. Okay? This over here, summation f, means I add up all the frequencies. What is the value of summation f? 30. 5 plus 12 plus 10 plus 2 plus 1, that's 30. Now at the bottom, look at this, fx. What do you think fx refers to? Yeah, f multiplied by x, isn't it? Can we do that? F multiplied by x. 0 times 5, what do we get? 0. Over here, what do we get? Okay, so on and so forth. 2 and 10, 20, 6 and 4. Have you seen this working yet? Have you seen this working earlier on? F times x? Yes, right? We saw it in our calculation of the mean. F times x. F times x. Then we get values over here. 0, 0, 12. Over here it is 12, 20, 6 and 4. 6 and 4. So the last one, summation fx. What do you think it refers to? We add everything up and we get 42. Okay? So the mean number of goals our working should be 42 over 30, which is 1.4 goals. The reason why I showed you all these working over here first, I show you all this because you can understand it. You know this is the way to calculate the average. But when we give students this formula, they may find it very scary. They don't know how to use it. But I am telling you, you already know how to calculate the mean. And the purpose of this example is to show you that, hey, summation f over here is simply the denominator, which is just add all the frequencies up. In our numerator, we have summation fx. It's simply the f times x and we add everything up. Same as the numerator over here. So nothing scary, okay? You know how to present your work for the mean. Minimum information I require will be a fraction showing numerator and denominator. Denominator easy, just the total frequency only. Numerator, something times something plus something times something plus something times something, so on and so forth, until every piece of data is accounted for. Okay, so now exercise number 9. We've got a mark scored by students again. Hey, there's an unknown over here, x. Okay, so now part A. The mean score is 3 marks. Find the value of x. Can I give you 5 minutes to think about it? Think about how you want to solve this. Okay, so this is the solution for part A. X equals to 8. So let's replace this with 8. Find the median mark. Every time you're asked to find median, what should you find first? No. Every time you want to find median something, you must find the median position. Okay? Always find the median position. Do you know how to find it? Let me remove this, taking up too much of my space. Okay, so write down median position equals to, where's the median position? You know how to find it? 22. Okay, let me count. 2 plus 3 plus 2 plus 4 plus 8 plus 3 plus 1 divided by 2. Okay, we must take the total number plus 1, then you divide it by 2. And what do we get? 11.5. Okay, this tells me that my median value is in the middle of position number 11 and 12. So what are the values of number 11 and number 12? So if I arrange all the students out like that, like exactly on the board, where is my student number 11? What is the value? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is number 11. This is number 12. So my median position is here, right? And the value, what is this value? 3 plus 4 divided by 2. So it's 3.5. So median equals to 3 plus 4 divided by 2, which is 3.5 marks. Okay? Now, do you need to list out everything like this in order to count? Where the number 11 is, where number 12 is? Can we just count from our table? Can we? I think we can do that. See, what is the mark for student number 1 if we arrange it out? According to the board, it's 0, right? The mark for student number 1 is 0 according to our board. Can we actually tell from here as well? Yeah, this is student number 1, you got 0. Student number 2 also got 0. Number 3, number 4, number 5 got 0. Number 6, 3, 4, 5 got 1. 6 and 7 got 2. 8, 9, 10, 11 got 3. So number 11 got 3. The next one must be 12. Student number 12 got 4. We don't have to list everything down. You can actually count from here. Okay? So the next question, find the mode. What's the mode? Yeah, mode is 4 marks. Mode equals to 4 marks. Now, part D. If one more student with a score of 3 marks is added to a group, find the new mean score. Can you try this yourself? Part D. So now, tell me, what was the original mean? Original mean is 3. Original average is 3. Now you put another guy who got 3. Does your average change? Make sense? One more time. The average originally is 3. Now you put in another student who got 3. So the total, if you want to calculate the total plus how many? Plus 3, right? Then you divide it by the number of students plus 1. Of course, your answer will still be 3. Because the addition of an average student doesn't make a difference. You can convince yourself by working it out. But in this case, this very special case over here, there's no difference. Okay? Find the new mean score. New mean equals to 3. there is no change since the new score equals to the old mean. X, number of students is F, and the unknown is K. Find K. You all agree? Part A, answer 14? Hello class? Do intact? Part A, 14 huh? Nobody disagrees. Okay, you're right, it is 14. Now part B, that's the interesting one. Okay, who say 15? Okay, I got 15. What else? 16? 17, any more? Any more? Okay, how do we decide? Which one is it? Okay, anybody wants to give a try to convince other people? Why is it 15? Why is it 16? Why is it 17? Huh? Class? Okay, again, who says it is 15? Who said it was 15 just now? I don't dare to own up. Sheldon, you say 15, right? Your friend sabo you. You say Sheldon say 15. So is it 15 or you change your mind? You change. What do you change to? 18. Why not laugh? Okay. Okay. So nobody says 15 now. How about 16? Who thinks it is 16? You change again. What do you change to now? Now you change to 16. Okay. So now it's between 16 and 17. Okay. Who would like to explain why is it 16 or 17? You want to give it a try, Sheldon, since you changed from 15 to 18 then to 16? You seem like you should be very, very sure already. Mechanics? 16, why? What? 6 plus 13, then? Minus 1, minus 2, why? Why? Okay, to find the median position, we need to add everything up and then we plus 1, then divide by 2 and then. So what is that going to do if you're working over here? Okay. So 6 plus 13 is actually 19. Minus the 2 for 2 people who have 3 mobile phones. So we get 17. And then she minus 1 again to get 16. Do you understand her explanation? Okay, let me try, Ken. I try one method, see whether you are okay with it or not. I am going to list down all the numbers of mobile phones. Okay, so here we have 6 people who have 0 phones. 1, 2, 3, 4, 5, and 6. Agree so far? But it's quite a lot to write lah. So can I just shortcut? I put dot, okay? Dot, 0. How many are there over here? 6. What's the next number? 1. How many are there? There are 13 over here. What's the next number? 2. How many are there? X number of them. I don't know how many. The next one? 3. How many? I might as well just write out, right? Correct? So there are 2 of them. Now we say that the median value is 1. We see that there are so many 1s. How many 1s are there? There are 13 of them. Every single one of them could be the median. Alright? But take note that exactly which one is the median. Is it this one? Is it this one? Is it this one? Is it this one? I don't know. It depends on how many 2s are there. Do you agree? Because I need to find the middle position. Okay? What happens if X is a... Now let's imagine, What happens if x is a huge number? Let's say 1,000. There are 1,000 twos over there. Where will the median position be? Where will the median position be shifted to? Originally, it's somewhere here, right? If I got 1,000 people who has 2 phones, the median position will shift to the 2s, isn't it? Okay, then it will shift over here. What if this number x over here is a very small number? Let's say it is 1. The median position will be closer towards the left, isn't it? Agree? Now I want the largest value of x such that the median remains at 1. Therefore, this is my median. The number 1 that is on the extreme right hand side will be my median position. You agree? Okay, if that is my median over there and that is my median position, how many numbers do I have over here? How many numbers are there all together? 6 plus 12. Agree? There are 18 numbers on the left hand side of the median. So how many numbers should there be on the right hand side? There are 18 numbers on the left. How many numbers should there be on the right? 18 as well. There should be 18 numbers over here. So how much is x? 16. Okay? How do we show working? Yeah, you can show this actually. You can show this diagram. Because it is very clear what we are calculating. Okay, for part C, I'm sure you can do it yourself.